confidence intervals for population means. Okay, so again, the difference between population means and population proportions. Means, we're now dealing with averages, average values. Okay, proportions are when we're dealing with percentages. Okay, in this section, we consider how to use information from a random sample to construct a confidence interval estimate of the population mean, mu. It's very similar to what we did with proportions. We'll have a sample mean, and based on the level of confidence we want to have, we'll open up an interval with a certain level of confidence to create this interval, just like we did before. Okay, so same idea, slightly different computation. We begin by considering the case in which sigma, the population standard deviation, is known and the sample size n is large enough for the central limit theorem to apply. Again, that's n greater than or equal to 30. In this case, the following three properties about the sampling distribution of x bar hold. The sampling distribution of x bar is centered at mu, so x bar is an unbiased statistic for estimating mu. From chapter 8, the standard deviation of x bar is sigma x bar equals actual standard deviation sigma divided by the square root of n. And as long as n is large, greater than or equal to 30, the sampling distribution of x bar is approximately normal, even when the population distribution itself is not. So, if we know the actual population standard deviation, we're going to use this formula. But this is very rare, okay? Remember, when we take samples, we're trying to learn something about the population. We don't know what the actual population mean value is, and we don't know what the true population standard deviation is. If for some reason we do have this value, we can use this for getting our confidence interval. The general formula for a confidence interval for a population mean mu, when 1, x bar is the sample mean from a simple random sample, 2, the sample size n is large, generally greater than or equal to 30, and 3, the population standard deviation sigma is known, we get, pretty similar to the last one, we have our sample average this time, plus or minus our z critical value, the number of standard deviations from the mean we want to go. Okay, the only thing that's different is that we're using x bar instead of p hat, and this was the way we computed the standard deviation for our sample means versus the standard deviation formula for our population proportions. Okay, so same idea, but in reality, we're really not going to even use this formula. Why? Well, for the reason I talked about a moment ago, and that we don't typically know what the true population standard deviation is. So if we're going to base our interval from sample data using the sample standard deviation, which is common, we do what's called a one sample t confidence interval for mu. Okay, so slightly different, but same idea. Okay, the general formula for a confidence interval of a population mean mu based on a sample of size n. Again, x bar is the sample mean from a simple random sample. The population distribution is normal, or the sample size n is greater than or equal to 30, and the population standard deviation is unknown. But what we do have is the sample standard deviation S. Okay, and then look at the formula. X bar plus or minus, instead of Z, we have what's called a T critical value times our standard deviation, and the only difference here is that we use S instead of sigma. Okay, so look, the only differences are that we use S instead of sigma, like we have up here, and we're using T critical value instead of a Z critical value. Okay, so let's talk about this T thing for a moment. The T distribution corresponding to any particular number of degrees of freedom is a bell-shaped curve centered at 0, sort of like the normal distribution curve, the Z curve. Each T distribution is more spread out than a standard normal distribution. As the number of degrees of freedom increases, as the sample size increases, the spread of the corresponding T distribution decreases, and as the number of degrees of freedom increases, the corresponding sequence of T distributions approaches the standard normal Z distribution. Okay, so what does this mean? All right. In a loose sense, a T distribution is a form of a normal distribution. that has slightly lower percentages of outcomes in the center and slightly higher percentages of outcomes in the tail regions. So, like if this is a normal distribution curve, okay, a t-distribution is basically the same idea. We're going to center this at 0, just meaning 0 standard deviations from the mean, okay? A t-distribution might look something more like this. Still has this general shape of a normal distribution, okay? But there's a little bit more area in these tail regions than there was in a normal distribution. There's a little less area in the center than there was in the normal distribution. And what ends up happening is that as the sample size increases, these t-distributions start to form more and more normal distributions. Okay, and so look, coming back down to the paragraph here, okay, we're not going to get too deep into degrees of freedom in this class. We don't really need to. The calculators will be doing the computations for us anyhow, okay? So don't worry too much about that. Really what you need to know is that, how do we do these confidence intervals? For sample means, we do a t-interval. That's what we do, okay? And on the calculator, we go to stat, over to tests, and we're going to scroll down to number 8, t-interval, okay? And there's going to be two different ways we can actually input this kind of information here. So it's going to ask you to input data or stats. We're going to use data if we actually have a list of data to punch in, a bunch of values, okay? We're going to use stats otherwise, like if we know what the average is and we know what the sample standard deviation are, we're going to use the stats. And you'll see, we'll go through, we'll use both in these examples coming up, okay? In any event, here's what the syntax looks like on the calculators. And notice, as you look at all this stuff, okay, you won't need to do any calculations based on t-values by hand. So that's why I'm not getting too into that here, okay? And again, in a loose sense, it's a form of a normal distribution. That's what you care about. That we use when we're dealing with sample means, okay? Let's take a look at the example. In a sample of 1,000 SAT takers, the average score on math was 500 with a standard deviation of 92. Find a 95% confidence interval for the actual average SAT math score. So based on 1,000 takers, the average was 500, and there was their sample standard deviation of 92. So n is 1,000, which is certainly greater than or equal to 30, so the central limit theorem applies. Okay, the average was 500, so that's our x bar. And our sample standard deviation was 92, so I'll write that as S sub x, okay? And we want a 95% level of confidence here. So we're going to go into stat, tests, and we're going to go down to number 8, t-interval. Okay, now here what we're going to do is we are going to enter the stats. Okay, so we're going to input stats as our input type. X bar was 500. Our sample standard deviation was 92. Our sample size is 1,000, and we wanted a confidence level of 95%, so 0.95. Okay, so punch that in or use some other online calculator to do that for you. And you should get an interval from 494.29 to 505.71. And what does that mean? Well, we're 95% confident that the actual average SAT score on the math section for all takers was somewhere between basically 494 and 506. Okay. All right, next up, a random sample of 36 teens who vape was conducted, and the average nicotine content of their vaping liquids was 15 milligrams with a standard deviation of 4.3 milligrams. What is a 99% confidence interval for the actual average nicotine content of a vaping liquid teens use? All right, well, let's take a look here. So again, it's the same idea. Let's see, n is 36, so greater than or equal to 30. We're good there with the normal distribution. The average nicotine content for the sample was 15 milligrams with a sample standard deviation of 4.3 milligrams. Okay, what was the 99% confidence interval? Okay, so same thing. We're going to go into our t interval, number 8. We're going to input stats. And here, x bar was 15. Our sample standard deviation was 4.3. Notice we don't have to do anything fancy with the formula here. Okay, we're not doing like sigma over anything. We're just putting this number right in. That's what the calculator asks for. Okay. Our n value was again 36, and our confidence level here 0.99. Okay, and I got back an interval that went from 13.048 to about 16.952. So what does that mean? Well, we're 99% confident that the actual average nicotine content of a vaping liquid is somewhere between 13 milligrams and 17 milligrams, okay, kind of roughly speaking. And in the last example here, just practice using the input of data. Test grades for a random sample of 30 students in a large lecture center style course are as follows. Okay, so we can see they go from lowest of 33 to a highest of 100. Okay, based on the sample, what is a 95% confidence interval for the actual average grade for a student in this course? Now, we're going to using the calculators input data this time. Now, if you don't have a calculator, again, go online and use a free standard deviation and average value calculator to just enter these 30 pieces of data, and you can very easily get the average and standard deviation from a calculator online. Okay, and then you can use the online calculator I've provided in Blackboard to come up with the confidence interval at that point. Okay, but if you're using the TIs, look, here we're going to do an input of data. Okay, well actually before that, so first thing we're going to want to do is actually enter all the data. I would recommend list one. Okay, you go stat, edit, and then enter your data into list one. So you're going to carefully punch those 30 numbers in, okay? Once that's all set, now we're going to go into stat tests, okay, and we're going to do number 8 again, a T interval. But this time we're going to input data. Okay, so we'll do our T interval, but we're going to input the data. So now it's going to ask you for a list, and whatever list you put in, you're going to enter that. I did L1, so I hit second 1 is how you get L1 in there. Second 2 would be L2, and so forth. Okay, frequency. Well, we're only counting this list once. There's one list of data. We wanted a confidence level of 95%, so 0.95, and let it calculate. And I was getting about 77.908 to 84.759. So based on a random sample of 30 students out of a lecture center course, we think that the true average grade for a student in that course is somewhere basically between a 78 and an 85, more or less. Okay, folks, so it's confidence intervals. Again, you just got to know how to input the data and just get the general gist of what this stuff's talking about, okay? A random sample of one value is one thing. Usually isn't going to exactly hit the mark in terms of the population mean, but now this interval that we've created more likely does, okay? So again, we're coming up with intervals that we think likely hold these true population mean values. All right, take care.